So I'm going to talk to you about our experience in trying to build capacity to expand radiation therapy education for medical physicists in East Africa. So just a little bit of history, just about the evolution of radiation therapy. X-rays was discovered in 1895, and 20 years later, we're using X-rays in the clinic. As a good Penn person, I must say that X-rays was actually discovered at Penn by good speed, so I've done my Penn thing to say. But if you ever have a discovery, make sure you publish it. If not, someone else will take it. So looking at from the 30s to the 50s, in the 1930s, cobalt-60 was discovered. 20 years later, we're using cobalt in the clinic routinely. Going from the 60s up to, say, 1990, now we're doing field shaping. Now we have a CT SIM. Now we add MRI and PET and all these fancy things. And looking at the some of the modalities today, now we've got proton therapy, things like photodynamic therapies. So my point is, radiation therapy changes quickly, and the technology grows fast. And so the education also needs to be able to keep up to speed with how our field is changing. So we're all aware of the issues of low and middle income countries in 2020, so I think this group doesn't need to really have this slide. But if we look at not just medical physicists, but also teletherapy units, and I don't have a pointer here, teletherapy units, as well as radiation oncologists, physicists, and therapists, we can see that this first group is Africa, then Asia, and then Latin America. So there's a need in Asia that's just as great, and in Africa and Latin America. But you can see that we work as a team in radiation oncology, and it's not just one piece, it's many pieces that have to come together. So when I think about building capacity, I think about like a structure. You know, you're building something, and there's many pieces to the structure. And if any piece is weak, this whole thing is going to collapse. So it's not just radiation oncology, it's not just physics, it's not just, you know, nonprofit groups. It's everyone kind of coming together and being, you know, aligned with the same idea. So Serby Grover, who's a radiation oncologist at UPenn, I'm sure you're familiar with, we have a partnership with Botswana, and she has implemented radiation therapy there. And so some of the things that she had talked about was, like, where do you get the resources for your needs? So for example, for training and improvement, you can look at industry or clinical partners, for data collection, NCI, for advocacy, NGOs. We can go down the list for retention of staff, the ministers of health, developing training programs, the ministers of health, IEA, clinical or education partners, purchasing equipment, again, IEA or PAC, commissioning. So again, the idea is that there are many pieces. It's not just if I want to implement a new radiation program, I need all these things to come together. And so the more that I've been involved in global health, the more I find out there are many people out there doing things. And so the idea is really, how do we bring all these groups together and really work together? Because I think that's the crucial piece. I think the resources are out there, but it's really the collaboration and trying to really focus on an area. So again, this talk is really going to focus on the education and training part in our experience. But just keep in mind that all these other pieces of the pyramid are also very important in order for that education part to be successful. So a little while ago, I saw a heading that talked about the variant halcyon. We'll hear a little bit later, but they're expanding access to cancer care in Africa. So they're putting 3 new halcyons in, 2 in Morocco and 1 in South Africa. But if you look at the places in Morocco and South Africa now, they have cone beam CT, they have, you know, LINAC, they have all the bells and whistles. So to go from that to a halcyon is not a big step. But if you look at a place like Ocean Road, we have cobalt. To go from cobalt to halcyon is a huge step. That's not just a simple, let's put a halcyon and everything is fine. The same thing with treatment planning. Those places have, you know, 3D planning, lots of experience, lots of training. Some places are still doing hand calcs. So to go from hand calc to like a halcyon is a huge step. I mean, so there really needs to be steps. And so I think when you think about building capacity, it should be, I'm gonna go from palliative care to curative care. And that should be, it's a process. And so I think you need to have a strategy and a plan to say, how do I get there from where I'm at now? And a machine is, just installing a machine is not going to answer your question. So if you look at the steps in the radiation planning process, first you have the patient assessment, you have the imaging, you have to do your contouring, treatment planning, pre-treatment review and verification, radiation dose delivery, quality management for every fraction, and then you have post-treatment completion. So there's multiple steps in this process. It's a very complex process. It's a lot of technology, sophisticated technology, and it requires the medical physicist. And so one thing that I did first is that if I'm going to help out, I need to know what is it like. I know what it means, what it's like to be a medical physicist at UPenn. I don't know what it means to be a medical physicist in Tanzania. So actually what I did, I came and spent a few days in the clinic as a medical physicist. Because if I can't walk in your step, how am I supposed to give you advice or help you out? So that was kind of an eye-opening for me, so I can see how the workflow actually works in the clinic. And then, I think that at that point we can kind of start to partner and come up with some ideas to work together. So looking at the radiation machines in Africa now, compared to the population increase, we can see that there is a need for more machines based on the amount of number of people in the country. But if we look at how the machines are distributed throughout Africa, we can see 84% of the machines are in 5 countries. Most of them in North and South: Algeria, Egypt, Morocco, South Africa, Tunisia. 16% of those machines are in sub-Saharan Africa. And so, again, so to go from something like, to go to a halcyon, I think that you need an intermediate step there to get people to just get people ready and capable for new technology that's coming to the clinic. And again, so this slide is something that this group is really aware of, so we don't have to spend time on that. So what do we hope to accomplish? So what we want to do is that we want to build a medical physics education and training program in Tanzania, a master's program with some short education courses, to have a regional training hub in this area. So this is an idea that we've kind of been working together on for a few years now. And so we think with MUHAS, who has a reputation of many programs, School of Medicine, master's, medical programs, and so they have the administration necessary to add a new program. We have the University of Pennsylvania experience in training medical physicists. So we've been doing this for some time now, and we do have a long history of actually training medical physicists, and we're currently in the process of moving the program to the School of Medicine. And also, the number of graduates from our program, 86% of them go on to residency, compared to the national average, 57%. So we do a good job in training medical physicists, of which I'm currently the program director of the graduate program there. And also the Harvard University Global Health Catalyst Summit, which is an excellent meeting. And so they really bring people together from many different areas, from industry, ministers of health, sports and entertainment. If you have the president of Varian and the Dikembe Mutombo and the president, and I guess, oops, what happened here? And stay. Okay. And the and also like medical physics and radiation oncology, all in one room, you can really make something happen. So if anyone, this is always a Memorial Day weekend, so if anyone has the opportunity to attend, I would really encourage that you attend this meeting. Also, they have developed an online platform that we are going to use in the program, but not just in the program we're working on, but also in other places. So I don't think it's actually been released, but it's called eCancer for All. And I think that even if you go to the website, they have some information about it. So this is the team that we have. So we have Ocean Road, Mulimbili, University of Pennsylvania, and Harvard, in trying to develop this program. So some things that we've done up to this point. First, we were just doing some Skype discussions about what is it that you really need. And so these are just some priorities that came out of things that are needed. And I just highlighted some simple fixes that we had, because one issue was, okay, the markings will come off because the skin is darker and sometimes I can't see the tattoo. So if the marks are gone, that means they have to start the whole process over again. We just simply sent paint pens to them, and that fixed that problem. It was that simple The other thing was that there was no portal verification that was done. So, so for the Cobalt machine, we did have a film cassette. We just sent them the film cassette, and so they could do some portal verification. So these, and the other thing was just some RayFax exams, because the physicists also teach the radiation therapists. They make exams and homeworks, and so we have all these RayFax exams, and so we had send them to them. So these were quick fixes that we could do. But there are other things that take more time. But these are the kind of things that once you start to talk and work with a group, you can see that, okay, there's some things that we can do very quickly. The other thing that we did in 2016, I think, was we did a course in quality assurance and radiation therapy at Ocean Road. And we also, I know this is hard to see, but we did a survey also, which is a pre and post survey of the course. Again, this is about building a program in Tanzania, not building a pen program here. So we need to know what is it that is needed here, and so that we can kind of develop the program based on the regional needs and with the regional resources. We also submitted grants. We submitted an R21, and the R21, this is just a Ames page. We had to resubmit, which hasn't been funded yet, but keep your fingers crossed. So the idea was that we wanted to build a radiation oncology core with practical and virtual components. So the practical would be the master's program. The virtual would be the platform that we have. And so this is the idea that we have. So this is the curriculum that, based on our experience and our discussion, comes from the IAEA also, but we did some modifications. So where can we help out? The areas that we can help out are the medical physics courses. So we have radiation therapy, radiation physics, and like some of the practicum training. Those are the things that we can help out now. It's really, we're trying to teach the teachers. Eventually, we'll step back, and the idea is that the graduates from the program will eventually become the faculty. But this is really, say, a 5 to 10-year program. And we think the other part would be the clinical training, where we believe industry can help out in that area. Because part of a program, you need to have some type of clinical practicum. The physicists in the clinic now, they're just too busy. I mean, how are they going to stop and actually teach a student in the clinic? But this is the area where I think industry can help out, where they can give the students some clinical training in the program. And also, if we look at the dissertation that's required, this is another area where I believe industry can help out. And also, in developing the clinic, things such as a protocol on how do we treat head and neck, how do we treat breast, how do we treat prostate. These things need to be developed in the clinic. They can be student capstones. So a student can work on these different protocols, which helps them in the program, but also helps the clinic. And so I think that these are kind of win-win ideas that we think we can implement for the program. Some other projects, an MLC for Cobalt. Cobalt is still going to be here. It's not going away tomorrow. I think that this is an area of research that can be further developed. Up top is antivascular ultrasound that can be used for liver cancer. This is a project that we're working at actually at UPenn. For us, again, a liver transplant is routine, but it's not as routine here. So this is something that can actually help with some liver cancers. Lawrence Korf from Indiana is working on some auto contouring tools for cervical cancer. So again, these are projects in addition to like the clinical protocol and some of the safety issues that can be done in the clinic. It can be done as part of the master's program. So also we can look at other ideas. So we don't have to reinvent the wheel. There's actually a medical physics program partnership with Heidelberg and Bangladesh, where this is a German academic exchange program. PAGO stands for Partnership in the Health Sector for Developing Countries, something along those lines. And so actually, they have a master's program in Bangladesh, and they partner with Heidelberg, doing kind of the same thing that we're talking about. And so this is something that already exists, and we've actually talked to them about the possibility of expanding their program and including us under the umbrella, which is possible. Because one of the struggles is funding. We do need some money in order to get instructors to the Ocean Road or MUHAS to do the courses. And so they offer not only the master's program, but the opportunity to have students do a PhD, which is something that is students actually really are something that students are looking to accomplish, not just the master's. They get money from industry to cover some of the study fees, and so for their planning for 2018, They want to provide access for e-learning, which we do have a platform that we're working on now, and they offer some QA lab work. Other things that they're doing is support for teachers and students. And so this is something that exists now, and that we can actually partner with them in order to accomplish our goals in East Africa. So some of the lessons learned is that things can be done in less time. Don't be too rigid on timelines. Limit your scope of projects. Physical presence, I think, has more impact than just doing things remotely. Maintain and build trust, which is huge, and also regular communication. The keys to success that I found was to work with an existing relationship, develop your memorandum of understanding early so everyone understands what we're trying to accomplish here. You need to establish recognition from the government for medical physics. So you can train medical physicists, but if the government doesn't recognize it, they're not going to hire them. And so that's very important as far as advocating that this needs to be recognized. Publish your results, design it around regional needs with regional expertise. Publish your results, and funding opportunities is something that is a struggle. So just looking at some of the lessons from our funding opportunity, this is just some comments that we received. One thing that I found was a big issue is that there was no one from radiation oncology in the study section. So like, how can we submit a grant and no one with that experience is on the study section? That just seems like, unreal to me. But some of the comments were that, it's important that Ocean Road has the variant accelerator. Why? I mean, that has nothing to do with what we're trying to accomplish. And, the faculty, who's teaching the courses. MUHAS has a long history of doing programs. And so it's like they're not even looking at what exists there now. The other thing that they mentioned, I didn't put on here, is like, they don't believe that they can administer a program like this. And I just showed you like a long list of programs that they've been administering in MUHAS. So we need to teach the people, the funding agencies also, about what global health means and the needs are. And also more funding opportunities, such as like an R25 type grant for global health. If we could create an education program that could be funded here instead of in the States, that would be great. And consider some foundation grants too. You may not be able to see some of the names, but that's another route. So finally, I just want to bring up some things that some upcoming events. So actually, after I leave here, I'm going to Namibia for the African School of Fundamental Physics and Application to talk about medical physics. Because these are the people we want to recruit. We want to recruit physicists in Africa to come into medical physics program. And so this is a conference, happens every 2 years in Africa. It's organized by CERN and Brookhaven National Lab. So this is pure physicists in Africa. So this is the group we want to recruit from. And also there's a program in Nigeria in September that we're doing, and part of it is that we're going to do like a 2D to 3D course. So if anyone is interested or wants to attend, this is the flyer for the program on the right side. And so our hope is, and I was talking to the physician from Ocean Road, that we're kind of developing this program. We want to come back here next spring to do a 2D to 3D course. And so that's the idea. So I think that's something that is actually necessary for a few places, I think, would like that. Not just a one-time, but this can be, maybe annual, biannual course that we can offer. Or even partner with industry where if you buy, say, a varying machine, then you also have this course. Because one thing we do at Penn is that we have a course for proton therapy where people come in, they take classes that we videotape, and we take them around our lab. We come out to their site, and so we can have something similar for low and middle income countries where we can have lectures that are recorded, and we can come out to the site, get them started, and this is kind of something they can do every year as a refresher. So again, I want to just thank Radiating Hope for inviting me, and I hope I can come back again to give you a follow-up on things that have been going on. Thank you.